All right. Good morning, everybody. Good morning, good afternoon, good evening, wherever you are. Welcome to the Embedded Machine Learning AMA. Very excited to have folks on the call as well as be here. There are some amazing people that are on the call. I'll introduce them real briefly, but first I want to just kind of give you a quick introduction about what we're doing here on this AMA. Embedded machine learning is opening up a magical real-world set of experiences at the edge. Many of you know about this from use cases in manufacturing automation, predictive maintenance in industrial settings, to tracking assets and helping with human interfaces and beyond. There's a lot of exciting work going on. And many of you often reached out to me because I've been teaching some of these topics and asking questions around okay, where is this future going? If I get involved in a career, where is this going to take me? And all these questions come up, and I don't necessarily have all the answers. But I figured, why not bring in people from industry and people from academia and try and get the next best set of insightful people to come and talk about answers to the questions that you have. So this is really an opportunity for all of you to get connected with us, personally be able to ask questions and understand where the field is going, how to land a career in this embedded space, and just learn something new. So with that said, I'd like to be able to bring the whole cohort that we have here. So if we can bring back everybody, the whole Brady Bunch, that'd be awesome. And real quickly, I will walk through every single one of these amazing people and ask them to give a quick 1-minute introduction about themselves, and then we can start diving into the list of questions you all have. Just remember, folks, this event is really for you, and it's for you to have a great time about asking questions and making the most of this. So feel free to ask any question you have. No question is too big, no question is too small. So let's have fun with this. That said, Jenny, would you please introduce yourself?
Hi, everybody. My name is Jenny Plunkett, and I'm a user success engineer at Edge Impulse.
Awesome. Jan?
Hi, I'm Jan Jungwelm, the co-founder and CTO of Edge Impulse. And in the spirit of the thing is my favorite quote: "There's no stupid questions, there's just stupid people."
Awesome. Pete?
Hi, I'm Pete Warden. I work on TensorFlow Lite Micro at Google.
Awesome. Daniel?
Hey, I'm Dan Sitanaika. I lead TinyML R&D at Edge Impulse, and I actually used to work with Pete on TensorFlow Lite.
Awesome. Marcelo?
Hi, I'm Marcelo Rovai. I'm a professor at Unife Brazil. I'm in the down south of the world to be here. Thanks a lot.
Lawrence? You're muted, Lawrence.
Hi, everybody. I'm Lawrence Moroney. I'm now unmuted, and I lead AI advocacy at Google. And I love that Jan shared a quote, so I'm going to share a quote of my own. And it's, "In a good cause, there are no failures, but only delayed successes."
Awesome. Marco?
Hello, I'm Marco Gennaro. I'm a research scientist at the International Center for Theoretical Physics, working on Internet of Things and development.
All right, that's the whole cohort. And thank you, everybody, for making the time to be here. Folks, these are some amazing people. One way or another, you've probably read a blog from them, or you've used the tools that they're building, or you've just seen them give amazing talks. So let's have some fun. So the first and foremost question is just generally talking about this would be what is embedded ML? Dan, maybe I'll shoot this question over to you.
All right, no pressure. I got to take the first one. So, to me, embedded ML, and it's kind of the idea of running machine learning at the edge where the data is generated, as opposed to in the cloud far away from where data is generated. And there are different subgroups within that. There's things like TinyML, which is embedded ML on really small devices like low power microcontrollers and things like that. Or we could be talking about a little bit bigger devices, so devices with maybe some kind of acceleration, like a Google Coral device or NVIDIA Jetson Nano. But the key idea is that we're pushing ML inference down to the edge of the network where the data comes from. And there are a bunch of really big advantages to doing that I will let someone else talk about.
All right, I'll pass it over to, let's see, randomly picking someone. Lawrence.
Oh, okay. Daniel's a hard act to follow. But yeah, totally agree with what Daniel's saying. And I think one of the important things is that, when you build models, you're going to build them on your fancy developer workstations or whatever, but it's where you execute the models. And if the execution of those models, if the inference is happening as close to the data as possible, then there's some magical things that you can do. I mean, not just, keeping data private and all of those kind of things, but there's the speed of inference, there's the reaction time. So for example, maybe you want a camera with a smart camera that can tell if there's a fire in your neighborhood. And instead of sending a video stream to the cloud, having an inference done on the video stream, dealing with connection issues and all that kind of stuff, if it can respond immediately, if it can trigger an alarm immediately, those type of things is really where, that's a relatively simple application, but it has a huge impact. And then start thinking about the other ways that you can have huge impact with models running on devices, even in areas where you may not have connectivity. And that to me is what's so exciting about this field.
Awesome. Lawrence, I'm going to double down on you on that topic around embedded ML. So one of the big things, right, because there are people here who are coming from industry, there are people here that are coming from academia, right, students and learners. So one of the key questions that I often definitely get is around what sort of background do you really need to be extremely successful in ML? Now, obviously, in this kind of context, we're talking about embedded ML, but let's just start at a high level. It's like, I want to have a career in machine learning. How do I go about that?
It's a great question. And I think one of the exciting things at the moment is that landscape is changing. 4 or 5 years ago, you probably needed to have very advanced mathematics. You probably needed a PhD and all of these kind of things just to get started. But nowadays, with the emergence of open source frameworks, with the emergence of relatively cheap compute, all you really need to be able to at least get started is just understanding of a high level language like Python. Understanding how data works. So being able to manage and sort data that you're getting in from images or CSVs or other things like that. So this is very, I won't say very, very basic programming stuff, but it's the kind of thing that if you are curious and if you want to get started with this stuff, it is relatively easy to get up and running quickly so that you can start at least building models. And then the next part is getting those models to run in embedded systems. And that's where things like the TinyML course is really, really helpful. And tools from the likes of Edge Impulse are really, really useful too.
So Marcelo, on this topic around teaching students, now I know that one of the things that you're doing out in Brazil is sort of like helping teach TinyML in a university setting. Could you elaborate on that? Because in an academic setting where students are just starting to come up into this space, right? What are they excited about? What are the things they want to learn about and so forth?
Yes. No, yes, it was a big challenge because we are trying to teach TinyML to students from for computing area, from electronics, and from control and automation. But in general, engineering undergrad students, they have a good C-level knowledge, and what we need to do was give again an overview of Python. And as Lawrence said, nowadays with frameworks like TensorFlow, it's easy for the students to really quickly understand how to build a model. And in the course we use a lot of Edge Impulse. So I saw students, try and work with COVID, TOS, and the sounds and a lot of things. And we are just finishing the 4-month course. It's a complete course from zero to really have projects. And worked very well. And it was I can say it's much easier for a student with a high, at least some level of C language to understand Python and TensorFlow and go from there. So basically, it was a very good experience.
Do you think this is a course that we would increasingly see in most universities going forward because there are certain fundamental concepts that can be taught?
Oh yes, I'm pretty sure. This is a new area, a new era, and I know TinyML is a kind of a revenge from us engineers. From a lot of time, engineers look for the academia for like deep learning, artificial intelligence. But at the end of the day, artificial intelligence is a lot of machine learning applications, and with all the tools that we have today, it's easier to go from idea to a real project. So we are now starting to see. We saw Harvard We saw Unifei in Brazil. We are starting to see the Instituto Federal de Education in São Paulo. We are starting with Mozambique. We know Columbia University we will start next year. So, I mean, I think it is blow. And I'm telling you, it's not the students from the last year of the undergraduate. We are seeing students from the mid course, blow their eyes when they saw that they can, take something so small like this, and this guy understand what they say, what they are doing. So, I mean, it's blow. And I'm sure.
Awesome. Thank you, Marcelo. So one of the things I'm trying to do here for folks who are kind of tuned in, what I'm trying to do is we started the education side and we'll slowly progress through in terms of what we mean in terms of like the industry side and so forth. So hopefully that'll kind of make the connections if you're thinking about why am I asking certain questions. I want to kind of progress from the academic side into the practical side. Now, building on what Marcelo was talking about in terms of actually getting educational material to students. Now, one of the things that Marco Zanara has been doing is actually trying to build an entire global network of universities where we systematically want to be able to share this knowledge. Marco, could you chime in on some of the TinyML 4D efforts that you're leading? You're muted, Marco.
Yeah, sure, absolutely. So when Dan said, many people don't have the internet, yes, let's not forget, half of the world is not connected to the internet right now. So to be able to use, technology, in these countries, we need to take into account, these limitations. So I have been doing Internet of Things in many developing countries. I had projects in 30 different countries, and I can tell you the biggest limitation is power and connectivity. So when I learned about TinyML, it really, solves these issues. So again, you have the data and you get, the computation as near as possible as your, phenomena in some way. So we're trying to set up a network of universities working in TinyML and interested in working in TinyML. And we're trying to solve one kind of very practical issue, which is getting devices in the hands of people that, want to develop models. So we already have people working in, plant disease detection or, in tea monitoring, many different applications, but they don't have the devices. So the first step in this project with Vijay and Marcelo is trying to get devices in the hands of, students and researchers in developing countries. And we're kind of successful in that, I would say. And yeah.
Yeah. Awesome. It's actually a really nice effort that Marco is kind of putting together. Marco actually reached out almost 8 months ago or something like that to Pete and me saying that, hey, maybe we can actually get this technology out, working with universities far out. So if this is a topic of interest, certainly you all know how to reach me. If you just look up my name, you can find my email address. Feel free to reach out because we're very passionate. All of us are very passionate about getting TinyML into the hands of people to be able to do things. Now, one of the questions that we have is, how much math is needed for TinyML? This goes back, Lawrence, around the topic of machine learning being a very theoretical subject. Lawrence or anyone wants to jump in?
Yeah, so I'm always one of those that I like to think of math is very important in ML, but it shouldn't be seen as a gatekeeper. You can actually get up and running with good TinyML stuff now without needing your to brush off your high school or college calculus and that kind of stuff. But once you are getting into ML and you are building models, if you want to refine them, if you really want to understand what's going on well with them, that's when you can you crack it open and take a look at, how are you using the optimizer? How are you using the loss function within that? What are the hyperparameters within that? And how can you tune them? And that's when you can begin to apply math knowledge to make your models even better. But it shouldn't be a barrier for you getting started.
So one of the cool things, Daniel, jump in.
Yeah, so I kind of wanted to expand on that. I think it's a really good question. Because if you look historically at what you needed to know to get into ML, if you kind of search around online, you'll find a lot of people talking about oh yeah, you got to learn this math, you got to learn this CS theory, etc., etc. And that was kind of the last era of learning ML. where the tooling to do this stuff was at a certain level of maturity that required a certain degree of low-level understanding. And things have moved a little bit forward from then, to the point that I think if you are looking to build applications using machine learning, you don't need to know the math. You don't necessarily need to know the like low-level programming stuff. If you're an engineer that works on embedded development or mobile development or web development, you can come along with those skills and then use high-level tool chains to help you do the ML part. And you're not, it's, you know, there's a big distinction to make between advancing the science of machine learning versus using the fruits of machine learning in your own applications. And those are two quite separate things. And you might be super interested in one of them or the other one or both. But right now, using machine learning in your applications doesn't necessarily require hardcore math skills or CS knowledge. If you're a capable engineer, you should be able to work with this stuff at a high level. If you want to go down the research route and start pushing the boundaries of, you know, what can machine learning do and how well can it do it, in that case, you do need to be a little bit deeper on the math stuff for sure.
Yeah, so Daniel, I'm curious, like what sort of platforms would you recommend at large that actually make it easy to be able to get started with ML nowadays?
Yeah, so I think, you know, I'm kind of biased because I can talk about Edge Impulse, which is our platform, which we've built, which essentially is designed as an engineering tool for embedded engineers who don't necessarily have any machine learning experience. So you can come in and basically feed in a data set and run some stuff automatically, which helps you figure out what the best model and signal processing combo is to do the thing that you want with that data set. So there are a few other companies out there with similar products, similar offerings. I think ours is the best, obviously. But essentially, that's one set of tooling. And then if you kind of go one level down from that, you've got these kind of high-level APIs that are exposed by other frameworks. So Keras, for example, is the high-level set of tools for building models within TensorFlow. And TensorFlow is it's like a big framework that covers the whole workflow of machine learning from start to end. And you can use Keras very easily without having a lot of background in ML. It's essentially kind of plugging layers together of models like Lego. So you do have to think a little bit about like model architecture and understand what you're doing there, but you don't necessarily need to understand the like nuts and bolts of what's going on underneath. But if you do understand, or if you want to understand or play with that stuff, there are loads of hooks that you can use to get in there. So it all depends how deep you want to go. And you can build really amazing applications without going deep. But if you want to do stuff that's kind of unusual, or, you know, pushing the boundaries of stuff that hasn't really been done before in terms of the type of problem, it can be helpful to go down that ladder a little bit.
Awesome. Yeah. So obviously I've been thinking about this quite a bit, and Pete has tremendously influenced me in terms of one of the challenges of bringing embedded ML to the masses is sort of having software frameworks that can work transparently over different kinds of embedded systems. For example, there's a question about, you know, things working on the Raspberry 2040. So Pete, can you comment a bit on like, when you're talking about the TensorFlow sort of ecosystem, right, which seems to be everywhere, like what are the challenges we run into? Because often I get a lot of questions around, well, can I use my own device for this particular microcontroller, right? Something that they have in their drawer. What are your thoughts around that?
So one of the things that makes this whole field so hard is that embedded development is really tough, just on its own, just writing, you know, regular programs for embedded development. And machine learning is this whole new field. And so we're sort of trying to do both of them at the same time, which makes it even harder. Now, we're helped by the fact that machine learning is essentially just math, which in theory should be very portable between different devices. But what we spend a lot of our time on is dealing with things like different kinds of build systems different kinds of tool chains, the fact that these devices have sort of different amounts of memory and different ways of programming. So a lot of the challenges actually come from just trying to set up very reliable ways to have software that can run on the ESP32, on the Raspberry Pi, Pico, on Arduino, on bare metal, on DSPs like Cadence or Qualcomm. And all of those have completely different instruction sets and very different build tools that we sort of have to adapt for. So in a lot of ways, a lot of our job is around getting that integration right. And we've actually really been helped by a lot of community contributions from, Arduino, Espressive on the ESP32 side, ARM, Edge Impulse are doing a great job on this stuff to help us kind of have reliable ways of running the same framework across all of these different devices. But it's definitely something where we can't do it on our own. We're very grateful for the different communities around these boards who have really helped and stepped up and sort of continue to help us get this stuff running. And we're always looking for contributions and help and collaborations. If you do have a particular board that you really like and you think that you would like to get this up and running on, we have resources to kind of help that, and we're happy to kind of try and offer advice and help.
Awesome. Thank you, Pete. Jenny. Oh, yeah, Daniel, jump in.
Oh, so sorry, I just wanted to jump in and say that's like a perfect example of how to make real impact in embedded ML, you don't necessarily have to come from this like ML educational background or be a mathematician or whatever. I mean, I'm definitely not either of those things. But maybe you're a pretty sweet C++ programmer and you can write some kernel implementations for a particular device, and that suddenly unblocks millions of developers who can now deploy machine learning models to those devices. So this is such a big field. There are so many places where pretty much anyone with engineering experience can participate.
Thank you, Daniel. Jenny, I have a question around supporting TinyML on the Pico 2040. Any thoughts around that?
So RDCam actually has a great, I think Artie actually answered it in the chat on the YouTube channel, but RDCam has a public repo where they've already generated a machine learning model for the Raspberry Pi Pico with Edge Impulse, and you can see all their code there. It's actually sort of based on the magic wand example that I think Pete can talk more about because he's done it over at Google. Yeah,
and to add that, we're actually, so it's even an M0 Plus, but we have a keyword spotting model running on the Raspberry Pi 2040 that is either already published or will be published very soon. Mm-hmm. So you can kind of start doing this whole range of applications, even on something as not as powerful as a Cortex M0 Plus with the Pico. So
yeah, talking about powerful processing elements, Jan. Obviously, in machine learning is we often kind of treat it as deep learning, right? But really, deep learning is just about neural networks, right? So how should people be thinking about machine learning in the context of embedded systems, right? One of the questions is, well, should we just use low footprint algorithms like decision trees and random forests, or should we all just kind of blindly close our eyes and jump in with neural networks?
So so I'm not an ML engineer, unlike, I don't know, lots of people I think on this call that really understand. I've tried to go through all the calculus. For me, the whole thing is, if there's a way for me not to use ML, then please do that, because everything is much more explainable. So yeah, I like my pipelines as lots of signal processing, go as far as possible as we can go through that, and then for the final part we'll use ML. And if that's neural networks, that's fine. Neural networks are super versatile. I think that's really awesome. So they can kind of mimic any type, or they can mimic most of these kind of classical ML algorithms, at least in behavior, which is, I think, really cool because it gives you that flexibility and easy porting, thanks to all the work that the TensorFlow team is doing. So for stuff like regression models, typically these days we just use neural networks because they can kind of do anything that this classical regression algorithms can do as well, and we get the portability for free. But other than that, for certain stuff like anomaly detection, we don't use neural networks because we can do as well of the job and much more explainable by clustering this data after a signal processing step. And for us, that's been something that's been in Edge Impulse from the beginning, because I don't understand neural networks. Like deep down, I notice what is happening inside after working with it for 2 years. But if I'm looking at the output of a k-means clustering algorithm, I immediately know why something is in a cluster or why not, and I can like deduce that away. Neural networks much harder. So it's a fine balancing act. Yeah, that's kind of it.
I'm particularly
no right or wrong.
About what you think around this point, because you teach so many machine learning courses at all different levels. So I'm curious what you think, Lawrence, about deep learning versus more traditional machine learning based methods.
Yeah, I'm actually, and I definitely agree with Jan. It's like, sometimes we can get into the habit of trying to solve everything with deep learning and trying to solve everything with machine learning. And there's the old joke that if the only tool you have is a hammer, every problem looks like a nail. And it's really good for us to be able to kind of look into and understand our problems first, and then see what we can do with our tools to apply to those problems. Often traditional techniques, like for example, something like anomaly detection, can hit limits, and machine learning can maybe help us bust through those limits. And when it comes to the point of view of education, that's really what we've been trying to drive with the education classes that we're doing, is that this is just another tool for your toolbox. This isn't something that you should be thinking about to throw away everything that you've done, unlearn everything that you know, and replace it all with machine learning. And I think if you can apply things that way, understand your data, understand your problem and the domain of your problem, and then start looking at the different techniques that are available in machine learning for solving that. Sometimes it's deep learning with a neural network, sometimes it's random forests or whatever, and decision trees. It really, really just depends on your problem. And I think, the best way to solve any problem like this is to do the research, to spread your bets, and, to see which ones work best, which ones are the cheapest to build and maintain, which ones give the best results, and then do the balancing act across all of those.
Yeah, so this is interesting. Yeah.
Oh, I was going to jump in there and say, this is where, if you were going to learn a little bit of maths, if you're someone like me who is not as mathematically inclined as maybe they should be, if you're going to jump in and learn a little bit, the best thing to learn is a little bit of stats, because the tools in stats that allow you to basically compare different sets of results and understand things like probabilities, those are what help you evaluate different machine learning models and help you explore data sets and figure out what is going to work best. So if you did want to kind of dip your toes in the math side, that's the most helpful part, because that can help you evaluate different approaches that you might want to take, rather than just using the hammer every time.
Gotcha. So one of the things I want to do is kind of to follow my thread, right? We talked a little bit about the education of the classroom kind of activities, and we started to talk about machine learning and how to kind of think about machine learning. One of the areas that I'd like to next kind of push towards is looking at industry applications and sort of scenarios and challenges and opportunities that are there in production scenarios. Because one of the questions I most definitely get a lot is, what are the real technical issues that people are facing when they're actually trying to deploy ML models? The courses kind of give you a feel, but they don't really tell you the hard problems that the industry is facing. So I'm curious, there's a question that's related to this. Let's start off with that. What are the obstacles to build models with machine learning, worrying about applications that need a very high accuracy and precision, such as in the medical case? Jan, perhaps you have some thoughts here?
Sure. Yeah. So I think the cool part here is that we work with industry, with customers that deal with this kind of problem. And the number one issue here is evaluating what the machine learning model says doesn't make any sense, and in what context is that. So for us, if we're working with customers in healthcare, the very first thing is how do we actually set up a data pipeline that lets us evaluate those metrics. So with a really large customer, kind of the first step they were not even thinking about ML. It's rather, how can we get 1,000 nights of medical data from people, have golden standard reference data, so put a bunch of ECG and EG pads on them, and then have their wearable collect data as well, and just that whole pipeline first. So after we can actually compare, so what does the ML model say? okay, what is the golden standard based on this, say, for much more sensors? What can we conclude from that? And once you have that baseline, you know that works, and we can progress on that. Okay, that's for healthy people in their teens. Okay, let's up that to older people. Let's up that to unhealthy people, and do this step by step in a careful way and with consideration of the real scientists that can actually make sense of these results. So it's much more of a data thing than an ML thing. Like once you have all the data pipelines set up and you know what you're looking at, the ML part is kind of push a button and get the model out. But this takes long engineering, right? This is this customer is like, we've been working with them for a year and a half. They're kind of finally putting this stuff in production because it's all this clinical validation that they need to do. And the ML part is just a small part of that.
Yeah, that's a really interesting point. I think increasingly what we're going to see, and Andrew has been talking about this as well, is that like we're going to start seeing a shift moving from focusing on how we construct the model, what model architecture we pick, and so forth, to actually thinking increasingly about the data aspect. Now, I'm sure Lawrence, who works with Andrew, would have some thoughts on it. Lawrence?
Yeah, absolutely. And I think one of the really, really important things that we've been discovering is not just the data gathering to be able to build your model, but one of the things that we see that as models are being deployed in runtime, and particularly in the medical field, that we really need to be careful in training people how to gather the data that's used for inference, because we have all of these experts gathering and cleaning the data that we're using when we're training the models, but then we put the models out in the field and there may be that lack of training, or there may be the lack of equipment to be able to gather data at sufficient fidelity to get the right answers with the model at inference time. So one of the things that we're seeing that is also necessary then for the pipeline of you training and continually updating and building better models, particularly for the medical field, is understanding how those models are being used in the field and understanding how people gather data. So then going back and then re-engineering your models based on, hey, maybe these people aren't as good at gathering like a data, like for example, maybe a retina scan, as I am or as this other doctor is. And so having that understanding of how the pipeline has to continue with low fidelity, poor quality data in the field is one of the things that really needs to be understood as you deploy and manage your models.
Yeah, so Mandy has got a question related to this around data management in the context of Edge Impulse, for instance. What's the process like for engineers at Edge Impulse when they support a new device into the pipeline? Jan, Daniel, Jenny? Any one of you?
Yeah. So the first thing actually we're thinking about new devices is talking. So we work very closely with the silicon vendors on getting this stuff in, or with device makers to get that in. So the first thing is really determining what is unique about this and what is kind of the use case that we see. And then we start kind of, I think the important part of what we do with Edge Impulse is make this data acquisition step as easy as possible. It's actually one of our, I think, we have three core tech engineering principles in my organization. And number one is everything starts with data. So it's the reason why we don't publish, like we don't have a model zoo, we don't publish pre-trained models, but rather get a dev board out, start collecting some real data, and then start building from there. So for us, kind of getting that down, and the first step there is let's make really awesome data acquisition clients, make sure we get data at the highest resolution possible from the sensor, have data integrity set up so we know which device generated data. So if something goes wrong, in the end, you can filter that stuff out. And that's really step one. And then our embedded engineers go and implement that efficiently on device. Yeah, data.
All right, well, I'll challenge you all with a tough question then. Since it's all about data, what's the image net of sensors for embedded machine learning?
Oh, I think Dan has some thoughts on this maybe.
Yeah, I mean, honestly, I think for embedded machine learning, we have a horrible shortage of data sets. So if somebody's interested, if there's someone out there listening to this who's thinking, I'd like to contribute to the field, maybe you're a student and you're looking for something to write a paper about, collect a data set that is related to embedded machine learning, because we've got these big data sets out there like ImageNet that are super useful for training vision models and things like that. But when you look at the sensors that are being used the most down on the edge, it's things that are a little bit more unheard of by regular people. So like accelerometers or vibration and current sensing, radar, like all sorts of like random things that you can basically integrate into an IoT device that are used for all sorts of different things in the field. But there isn't a lot of data out there because you can't just scrape the internet and find a load of accelerometer data the same you can with image data. So I think, there's huge potential there for people to try and capture some of these general big data sets around specific sensors that we can then use to train or to evaluate different types of models and architectures that would be helpful in a general sense on the edge.
Yeah, one of the biggest shortcomings, I suppose, like in a lot of classroom-related activities, is the fact that the data sets are usually given to you. So I'm curious, like Pete, like if you have thoughts around this, because you've obviously, you work with many different end users who want to do something with ML, right? Curious if you have any thoughts or large you can share from like a Google perspective, for instance.
Yeah, I mean, I think the thing I keep coming back to is this data, the data side. And also, coming back to something that I think Dan and the Edge Impulse people were saying earlier about really people almost don't have trouble with the ML part. They have trouble with the defining their problem and gathering enough data to actually, even just evaluate whether their problem is being solved. And we saw that even with Kaggle. A lot of, if you're not familiar with them, they're sort of a data set as a service, it's essentially they're a service that works with companies to try and put together data set competitions. And I've known them for years, and really what they say all the time is that they spend the majority of their work with these companies not on sort of gathering a data set, but just trying to define what the problem is and how to evaluate whether the problem has been solved well. Because we come in with or people have problems, but they're not necessarily able to define them in the kind of mathematical, scoreable way that we need to in order to apply a machine learning solution to them. So I really see almost everything coming back to, we have now these pretty general purpose tools. If you give them the right kind of data, we'll probably do a sort of a half decent job at recognizing patterns and coming up with kind of scores based on, I found this pattern versus this pattern. But when it comes to actually getting them out into the real world, trying to figure out how to define which things you're actually looking for and gather data to back those up is still the blocker for almost everyone.
Yeah, it's interesting. I often feel like, one second, Mark. I often feel like what ends up happening is that when we're talking about machine learning, everybody just wants to get their hands busy and going. And it's, when you're teaching computer science code, right, one of the first things that we're ever taught when about programming is sit down, write down the pseudocode. Pseudocode is extremely important because you want to get the concept right and forget about the machinery, right? And that forces this very methodical sort of thought process. And often I find that I see like that's a big missing hole right now, that sort of mindset of how to go about solving problems using machine learning is still not kind of sketched out in a lot of detail. Marco, do you have thoughts on this?
Yeah, yes, just to add something, that if, data sets are not there for, applications in like developed countries, if you look at developing countries, it's even harder, right? So I have a student working on disease for cotton plants in Benin, and there's no data set for that. So they need to gather data, locally, of course, which takes super long time. There is another student working on an acoustic rain sensor. So worked fine in Italy, where she, used Edge Impulse to, design her acoustic rain sensor. But the sound of rain in the southern hemisphere is different from the one in the northern hemisphere. The size of, raindrops are different. So there again, we need more data, and looking at developing countries, we need again to have devices so that they can gather data for issues that are relevant to their specific environment.
That's a great point. Yeah, Marcelo, please.
Yes, complement what Mark was saying. For example, regarding data set, it is the most important thing for sure for any machine learning project. But for example, talking about keyword spotting, for example, as you have done in the Navarro University with the Harvard, VJ, when you got all the students that participate in the seminar, they capture one word in their specific language. For example, we did the same in Brazil when we developed the keyword spotting application using AdImpulse. So all the students got one word, was Unifei, the name of the university. So we could get 20 students, capture a lot of words, and we put all that together. And we try to use some Portuguese words to use the background, because unfortunately the pitch data set that is fantastic, but it's all in English. It's important to have the other words. So this is we need to have. So maybe with this new academic network, we can do that in several languages, and it starts to have data sets to work. I think that will help.
That's a great point. Jenny, could you chime in a little bit on like this blog post that I saw recently from Edge Impulse, where you folks somehow set something up to be able to collect data? Could you comment on that? Maybe post a link as well, please. Oh,
yeah.
You did.
Yeah, I posted the link in a private chat. I don't know if I already posted it, but recently VJ and I did a little workshop with the Crestlex crowd in Harvard. And basically what we did is during a live workshop, we had our entire audience basically crowdsource a keyword spotting data set using their Navajo language. So we were able to correctly identify the audience saying the keyword. I can't remember what it was, but it was basically hello in the Navajo language. And I've written a blog post because Jan, our CTO, has written a tool that allows us to really easily create these unbiased, robust data sets for keyword spotting using Edge Impulse. It's super easy. All you have to do is send a QR code to your audience, and you can have your audience record all those keywords and upload them directly into your project and start training on a bunch of different types of voices. I know personally, because I'm a female, a lot of the keyword spotting models out there were trained on only men's voices or only people with American accents. So it can be really difficult to make these really ethical and unbiased models. So having these tools will just make everything really easy for us in the future.
Awesome. You prefetched a topic that I really wanted to double click on, which is sort of how do we encourage more diversity and support in the embedded ML space at large. Of course, this is a general problem all across the space, but we are all working in the embedded ML space, and all of us have a lot of projects or passionate things that we're doing around this space. Would anyone like to take that one? Lawrence.
I think, sure. I think I can, because I'm particularly passionate about this one. And I think one of the biggest things that I've noticed that I've been trying to increase diversity and representation in the TensorFlow community for the last couple of years. And one of the things that I've noticed that has been the most effective is also the most obvious, and that is to reduce the barriers to entry as much as possible. And so it's like the barriers to entry for women are generally higher than they are for men. The barriers to entry for non-English speakers are generally higher than they are for English speakers. So if we can like bust away as many of those barriers as possible, then it's not going to solve the problem, but it's going to begin driving us in the right direction. And so things such as we were talking earlier about like needing a lot of math, like trying to bust through that perception that no, you don't need to be a college level graduate in calculus to be able to get started. And also in providing people with the tools that they need, the frameworks that they need, the data that they need to be able to get started, proper training, making that training freely available as much as we could. You know, the TinyML courses can be audited for free. The Coursera stuff that we teach can be audited for free. And like, you know, really as being as focused as we can to think about where would there be barriers for people that there may not be a barrier for me, it may not be a barrier for anybody on this call, but let's start thinking out of the box that there are people out there that will have barriers for this. Do they need high bandwidth connectivity to be able to download this stuff? Is there a way that we can cache that for them to make it quicker in their area? And to bust through as many of those barriers as possible at least as the first wave of increasing diversity and representation. And, you know, like I measure the stats on some of the things, like, and I give an example is that I've run the TensorFlow YouTube channel, and like we've been applying this strategy as much as we could. And like over the last 2 years, we went from, you know, low single digits viewership amongst women to like about 2%, I'll say, of viewership amongst women of our videos, to about 15 to 20% viewership amongst women by doing these kind of things. We've also increased viewership amongst countries that weren't traditionally reached, you know, countries in South America, countries in Africa. And it seems that at the very least, and it's the one thing everybody can do, you don't have to be Google, you don't have to be Harvard, you don't have to be Edge Impulse to kind of think about where the barriers are and reduce them as much as possible. And it really works.
Awesome. Thank you, Lawrence. Anyone else want to jump in on this? Dan.
I guess I can say something quick as well about, you know, if we want people to join our field, then we need to have a field that is an example of something that's making a good influence in the world and not a bad one. And I think if you look at a lot of things in technology, you can find so many ways that technologies have been deployed that are harmful, whether it's to minorities or to the climate or to whatever. And if we want loads of people to come and work in our space and help build these technologies, then we need to all work in a way which is beneficial to the world and attracts the right kind of people. And so that means things like thinking about ethics and AI fairness when you're building and training and deploying models, thinking about what types of application are you going to support and allow people to use your tools for, and how do you make sure that your company or you as an individual, you're making a good impact in the world using this technology, because people aren't going to want to come and work in this field if it's seen as a field which is detrimental to the world.
That's a great point. I think the thing that you definitely resonated with is actually focusing on the value and not so much on the mechanics. Now, I can tell you firsthand from, you know, having taught in university classrooms for about 10 years and with very few female students, out of like maybe 80 students, I'd have like 1 or 2 female students. I kid you not, especially at where I used to teach at UT Austin, where I'd have like 400 students in a class. It would just be like literally 5 or 6 girls, which is terrible. Yeah. And the interesting thing that I learned, that when you ask like, well, why are you all not excited about taking the class? And they often say like, well, just kind of think about the way you're going to teach it, right? Which is like, you focus so much on the nuts and bolts of like 1 + 1 = 2. It's like, oh, you got to know this addition. Well, is that important? Or is like, what can I do if I know that I can build this tool? I think that's what that's what I hear Dan saying, is like, if you focus on what you can do with some piece of technology, that seems to resonate more at large, with a much larger sort of community, rather than being like, oh, check out this cool widget or this tool like Edge Impulse or like this tool like, you know, TensorFlow, or like, I'm just kind of making examples here, right? And that seems to be the big differentiator. And I think like I take that personally as an academic, which is like, you know, how do I increase, how do I shift my own teaching, right? And I think this carries out to no matter whether you're teaching, we're always teaching somebody or the other, right? I want to ask Jenny, not to put you on the spot, Jenny, but I'm curious, because of all people, you would honestly have the more direct sort of insight into this, right?
Mm-hmm. What is your question? Is your question, you know,
I'm curious, like how you think we should be going about teaching embedded machine learning, or just machine learning at large, to the community?
Well, I mean, in terms of, if I was taking an embedded ML course in my college, I would want it to be highly technical, but only because I had an electrical engineering degree, and that's sort of what I would expect out of the class. But I found my favorite courses and my favorite projects in college are always application based, or some sort of industry focused project, or something that has an end goal or an end use. That's what I found the most value. But yeah, I can read research papers all day about machine learning and different mathematical proofs, but that's not what I remember from my college experience. And I'm sure my other colleagues and other students in my class from UT Austin would attest to that.
Yeah, I'm sure we can all do better. And I think like one of the reasons I always like to touch on this topic is because unless we kind of make it front and center, we're never going to like really sort of address what we need to do about it. So that's why I'm passionate about it. So hopefully people are comfortable with the fact that I brought it up. Awesome. So I guess like one other thing, like as we're reaching towards the end of the AMA, are technical questions. Since I've been avoiding the super technical ones, there's one question I think that goes at Pete specifically. I've got a lot of this coming at me all the time because we use TensorFlow Lite Micro in our course. Everybody wants to know what's coming down the pipe, what does the roadmap look like, and where are things going with TFLM?
So we still have a lot to do in terms of just supporting different ops and different models within TensorFlow Lite Micro. So there's a lot of work that's just continuing as people come up with new research techniques to build models that are better. We kind of have to jump on, okay, we need to support the ops that they use. We're also seeing new platforms constantly appearing. So we're working on those. And I see there's also a question here about different quantization techniques. That's an example of another area where we're looking seriously, especially 4-bit. That seems to be a very practical use case that a lot of product teams are asking for. But fundamentally, a lot of what we have on our plate is driven by the applications that people are trying to build. So if we can hear from people who have a problem that they're trying to solve that they can't currently solve with TensorFlow Lite Micro, whether it's, hey, you don't support this op, you don't support this quantization technique, you don't support this platform that I think is a really interesting platform, that's fantastic feedback for us. And that actually is what helps drive our development. So I know it's a bit of a hand-wavy answer. It's honestly is just like pushing forward the whole thing. We have so many really cool applications that people are building on this stuff that people need help with. We're just trying to be this group that really helps enable other people's success.
Awesome. Thank you, Pete. We got 5 minutes left. So one thing I'd like to do is to call on everyone, and specifically I'll ask my favorite question, which is, what are you most passionate about? And specifically, obviously, in this context, it's going to be around the embedded ML space, right? It might be around education, might be around outreach, might be around diversity, but whatever it is, what are you most excited about? And what is it that kind of you think that we as a community can do? Because all of you are on this call, because I know firsthand from having interacted with you that you all like to think more than about what is in it for you, and it's about what you can do for the greater good. And that's why we're all here, right? So Marco, what are you most passionate about in the embedded ML space?
So getting devices in the hands of people that might have super interesting ideas. And second, having a platform whereby people can share their models and their solutions. I've seen it over the years, in sensor networks, in IoT, people coming up with the same solution in different environments. And it's, I think, a waste of time. And it would be wonderful if people could, share their solutions in some way.
Yeah, some way to kind of network and kind of have a shared sort of experience. I think Hackster.io, I was looking around, like does an amazing thing where people get to share these different things. And I think I see a bit of ML there. Yeah.
Yeah, cool. So for me, the most interesting part is once you build a tool and it's easy enough for people to actually do something useful for, there's a whole flock of people that are certainly going to use it for novel stuff that you never thought about, right? Lots of conservation stuff. All of a sudden, people are doing on Impulse, but that's going to be even more. And that's, I think, the next wave of ML. Right now, there's the front runners, people that understand this stuff like deep in, and they build some tools. Right now, we're going to go into a certain part of maturity where other people that don't have any experience in ML or maybe very little experience in embedded software that are now going to take this and apply it on really awesome use cases. And yeah, it's going to be amazing. Like if you already see going a year and a half ago, 0 project on Edge Impulse, now 35,000. holy fuck, like in this tempo, we're going to be 200,000 or something by the end of 2022. Like, just imagine. Yeah.
Yeah, it does say something, right? It shows about the amount of interest that is there. I think the one thing that we could all do is kind of help provide the community what it needs. I think EdgeImpulse does that in a way, providing a tool that kind of helps it. TFLM does that and making it easy to support different heterogeneous devices and so forth. Yeah. Jenny, please, what are you most passionate about?
So personally in the space or with my job, I'm really passionate about presenting TinyML to large audiences and workshops of people who are using our silicon vendors, chips, and seeing their eyes light up when I do these workshops, and they start, commenting in the Zoom chat like, oh my God, I can do this and this and this, and then it's so much easier than I thought it would be. Like, that's what brings me so much passion to this field. It's bringing this level of knowledge and into the field. It's like it's completely reduced the barrier of entry, and I'm really excited what people do in the space.
Awesome, very nice. Dan.
Right, so I mean, for me, I think that embedded machine learning, this is going to completely transform the way that humans interact with computers over the next decade or so. I think that the level of impact this technology is going to have is completely invisible to most people, including most people in the field of technology. I think that it's going to be something that's, as big or more important than things like mobile phones or personal computers, is the idea that you can capture a little bit of human knowledge in an algorithm relatively easily and deploy it to a place where it's needed, and make household items come to life with a little bit of human understanding. And I'm just so excited about that, and I'm so excited about building tools that let everyone in the world who's an expert in some little piece of the world capture that knowledge and deploy it into our technology. We're going to be living in a magic world pretty soon.
Awesome, thank you. Unfortunately, Pete had to drop, but knowing Pete, I know Pete's excited about a lot of things, and I'll tell you the one thing he's most excited about is giving access to technology, the embedded ML technology, to a lot of students and university courses. And then he's worked very closely with me to help us kind of bring it to the university. And he's actually working very closely with high school related activities and so forth. So let me move on to Marcelo.
Yes, thank you. Guys, I'm in love with this subject, and I must tell you, don't let, I don't have the hardware, I would like to have the kit. I heard a lot of it. Guys, I did the VJ. This is the kit that I used in the VJ course. Let me see. Look, I did everything. I did the person detection. I was a pain of ass. It's difficult, but we can do it. Go, put your hands dirty. Take your hardware. This is another one. Look, mount. Went to EdgeImpulse course. You have a fantastic introductory course that you can use all the platform. Understand how to go from idea to the project. After that, go to Harvard X, the EDX. It's a fantastic, it's a longer course. You learn with VJ, you learn with Pete, with Lawrence, you see, you can really enter and become an embedded machine learning engineer. It's my advice. Go and do it, that's it.
Awesome, love that energy, Marcelo. Now I feel like I have to go take this all this stuff. Lawrence, my things. Lawrence, you are amazing at outreach and sharing stuff around now. Very curious to hear your thoughts, and I'm also like, it'll be great if you can kind of talk a little bit about the broader sort of vision that you have around TensorFlow and what the TensorFlow team does.
Sure, Marcelo's a hard act to follow. So I think, the thing that I'm really passionate about that like really fits into what answering the question that you mentioned, VJ, was really, I kind of like put it in 3 words, and it's democratization of AI, or is that 4 words? And it's like when we think about all of the promise that we've been talking about, I love how Daniel described this like magical future world, and all of the potential promise that's out there, all of the excitement that's around AI. I mean, this is coming, this can happen, but it can happen better if it's in the hands of more people. When we think about like the mobile phone explosion, or we think about the explosion of the web and that kind of stuff, and like we changed the world with those two tech revolutions, but in many ways the wealth and the ability and the knowledge base and all that was kind of very much centered in very few places, like Silicon Valley, places in Western Europe, and that kind of thing. With AI, and particularly with TinyML, where you've got the cheaper hardware on which these things can run, it doesn't necessarily have to be centered in those places. So what I'm particularly passionate about is really that democratization of AI, making it possible for anybody in the world to be able to do this, so that we can break through the hype cycle, we can understand the type of applications that can be built. And folks in the traditionally underreached areas are the ones who can come up with the solutions that the rest of us don't think about. When we think about the solutions that do really well in mobile phones, those are the solutions that are solving in many ways what they call first world problems. There's some great ones out there, but think about the solutions that can make the world a better place, that people in emerging markets, that people in traditionally underrepresented areas can think of, can build, and then everybody can take advantage of. And that's my particular passion. And how we get there is, some of the things that we spoke about earlier on, reducing the barriers to entry as much as possible, free software, free open source software, having things like online, I'm sorry, I don't mean to make this sound like a sales pitch, but at Google, we have something called Colab, which I'm really, really passionate about, which is giving people the ability to use GPUs and TPUs in the cloud so that you can start training some of these large models. Having low-cost hardware such as Edge Impulse and the services from Edge Impulse and low-cost hardware on which they can run, so that people don't need to invest millions of dollars to be able to just get started. Having open education, having open lots and lots. I think it was somebody mentioned earlier on about like having lots and lots of great samples out there, so that people can dissect these and can start working from them. And that to me is really where we'll be starting that engine that drives AI throughout the rest of the world. And again, I'm going to go back to Daniel's phrase of having that magical future, and I think that's how we can have that magical future, when it's in the hands of as many people as possible.
Awesome, beautifully said, Lawrence. I often just say that I feel like we're in the Wright brother days of building airplanes. As exciting as things are, it is such a bright future to be at, like that we're going to unlock. And I honestly believe that it's that next generation that is just going to blow our mind with this technology. Like we're just on the cusp of just giving it to them. Right now, we're busy just making it accessible. What's going to come out? Well, it's yet to be seen. So with that said, folks, we're a little over time, but thank you so much for making the time. It's the fact that you all are so engaged and you ask questions, or you reach out to so many of us that kind of lights the fire to do these things. We do this because we're all excited and passionate about it. And the more you push us for the kind of things that you want, the more we're going to support these kinds of activities, right? So please keep the passion up for this topic. We think we're all about to unlock a bright future. With that said, I want to give a shout out to two folks you're not seeing on the call because they're doing all this magical moving of things around. That is Alessandro and Artie. Greatly appreciate all the support and support. So thank you so much. If everything has gone well, it's because of them. So thank you all, and we hope to hear from you one way or the other.